So we're doing Leetcode 3, and before anything else, establish everything, of course, right? So the character we are introducing now is um, 3, and specifically where um, I think talking their first search. I think overall cause we trying to find a height, so that's why. So conditions, obviously we cast spells, and for every Leetcode question there's always some form of like rulebook, and in here we have like the playout series. Cool. Now in terms of like the core objective for overall scheme of things, I think it's really come down to actually what they ask us to is they want to find whether it is balanced tree or no, and how you actually find balance is pretty much checking the max heights for both sides, and then you kind of like make a comparison, and for this specific case is no more than 1, right? So that's the core objective overall. In this playout series is it just like fundamentally just uses this formula per se, which is 1 you plus the max of either sides. So that's fundamentally what you are gonna like reiterate at every single node. That's what's gonna actually happen, and pretty much it. So say for example I have a node here, right? So here I don't have any children for here, so I'll register this as like 1, and notice that I'm starting from the lowest to the top. That's how we actually gonna reiterate. And obviously there's like the this one, it will be operation Z, which is the right one, but obviously there's gonna be a counter argument that why not start from the top, and that's operation Y per se. And I'm just gonna play out both series, both operation per se. So operation Z, we're gonna conduct it right now. So you come to here, no children, you max height, you apply the formula 1 plus the max. Then obviously no children, that means you 1 plus 0, you get 1. Same for here, 1 plus 0, you get 1. And that's each time. So like there's actually 2 operations that's actually going down when you actually execute all of this. Is that for operation W is to conduct the formula, and operation U is basically you pop your value back up to the top system. So similar for here, operation U, you're gonna bring your value in and pop it back up to the top, to the root that is above you, your parent node. So you come to here, you're gonna do this similar operation W and U per se, and what's gonna happen is that you apply the formula operation W, 1 plus max, and obviously either sides you can take one of it, and then you get a 2. And not just that, you're gonna operation U, you're gonna return back to the parent node, and you're gonna pop it back up. So you're gonna send the system to say that there's 2. So you come to here, you apply the same formula, operation W, the 1 plus the max, And obviously you're going to start over here first, because we want to check both sides, right? So you come to here, you 1 plus no children, so 1, pop back up, come back to here. Cool. What you're gonna do, 1 plus the max, obviously 2 is bigger than 1, plus 2, you get 3, and that's your answer. And that's when you know that, I mean, you're at the roots. And one more operation that we got to actually do, operation L, which is you kind of like check your children's notes. Are they sort of like the difference between both children's? What is it? If it's sort of like more than 1, then you're gonna like give the value false. And obviously when you have a Boolean false, obviously that's a true. So if it's like less than 1 for the difference, you're gonna pop true. So you can imagine that if say you get a false value, you're just gonna stop the whole loop and say that okay, it's not a balanced tree, right? If not, it's a balanced tree. So each time you do this, sure, you are sort of calculating the height, because I mean the reasons why you are sending back the recording of like the height per se is that at the end of the day you still want to know what's your total height at this juncture, and at this juncture what's like the total height, so that you can start doing the comparison. So that's the main reasons why you always pop back up your value, which is the operation U, so that you can compare thereafter, which is over here, the overall of left and right. You can start doing the comparisons, which what we did. So you can perform operation L, where you calculate the difference by having values that say that you are popping back the value up. So that's the main reason. So obviously we were talking a lot of like operation Z, which is the most efficient way of doing things. If you will actually realize this, is that whatever we're doing, we're using operation L and U, and there's a reason for this, and operation Y is going to explain about this. So say for example, if I come to this value, I need to check which is the main item for the rulebook, which is saying that no more than 1. We need to check the balance of 3. So here I need to go in and check, perform and check where is the deepest of the left side, where is the deepest on the right side. So maybe say I go to here, cool, and then I go to here, cool. I mean, I go to here, the deepest, and then cool, it's still valid. Like I actually need to perform on this item, yeah, honestly what I'm actually doing is I'm performing on this. The time that I perform onto this, I need to check for this item, and then this item, and then this item, to be able to check for this. And if say I want to check for this item, I need to check for this item and this item to complete this. And when I come to, then we say that okay, this is balance, I come to here, I want to check with this balance, I go to here, I check this, so that I can make sure that okay, this is right. And I come to here, I need to check, so this is cool. Come to here, I need to check, this is cool. I'm getting the intuition that say that this is like I know they already explained that is this also is a big old operation of n squared, because what I see is that if I need to check for this item, I need to go here, I need to go here, I need to go here, I need to go here. So there's one pattern. Second pattern, if I want to check here, I need to go back here and check again. And if I want to check for here, I need to go here, I need to go here and here. It's like a lot of like repeated work if you were to see. I need to check for here, I come back here and check. I will come here, I check for this one individually as well. So as you can see, a lot of like repeated work per se. And if I were to find something to actually fight against this operation Y, I'm gonna like choose operation Z. What operation Z, it actually visit each node just one time, but operation Y, it just feels like it's repeating visiting the nodes multiple times, because they need to check for each node from the top. It's very hard to check. And if you were to see operation Z, what is actually doing to be able to actually fight operation Y per se, is that operation Y visits every single node, but operation Z, it records values, which is operation U, where it pop values back up to the system as sort of like a memory, so that you don't have to revisit certain nodes on the nodes that you have visited. I think, to me at least, when you actually fight operation Z and Y, I will argue that the mechanism of U is the main reason why this works, because it records memory, it pops back up, so that you don't have to revisit the value again. Incredible mechanism, in my opinion. So with that said, we can see that whatever the Leetcode is asking is this, that we want to find at the end of the day, is it like balanced tree or not? And when you talk about balanced tree, you're finding like the difference of the height. And with that, this item over here, it's able to actually conduct it really well by casting this spell, depth first search. And if we were to actually see what is depth first search, I mean, actually, to me, my impression of depth first search as of right now, my impression of it is that it just go as deep as possible. So when we are actually doing a circle, trying to perform a DFS over here, we make sure like this item is like the deepest of the deepest, and we can guarantee that this item is like nowhere deeper than we can go. And similar for here, the deepest item for here. So therefore, whenever we actually apply this formula, is that we are 1, which is this current node, you plus the deepest of this item, or deepest of this item, so that you know you are actually entering the deepest of the forest. And same for here. I think to me, that's the meaning of DFS. And DFS, under the hood, it has like a formula to make sure that it goes the deepest of this current node. If say there's like a children's like deep down, DFS when you perform to here, I believe that it will go travel all the way down. And that's what I believe, and I truly believe in it. Yeah. And I think the beauty about this overall mechanism, item number 1 is that it sort of utilize a lot of like the reiteration of the item, whereby you can apply certain formulas to reiterate itself. So for this very case, it performs multiple operations. Like it can reiterate operation U, W, L, which at the end of the day, which is like the core roots of like each of them have its own property. And say for operation U, it sort of act as a form of like memory. And I would say that operations maybe W, it just stores the current heights. And then last but not least, operation L is to actually, answer the question of like, why did we actually head out to go to the forest in the first place, which is to actually solve the core objective of the Leetcode question, which is to actually find the max diff of the height. So as you can see, like when we talk about reiterations, I mean reiteration, the first thing that you actually think about is that this is actually what tree specialty is that it's able to actually reiterate a mechanism like the operations very smoothly, and for each of the operation it has like its own meaning, and when you need that, you can use trees to actually do that. And I just feel like this tree, it has this specific spell of like DFS, where you search for the deepest of the value, which is what the Leetcode question is actually asking, which is that they want to find the max difference between the height. And the passive spells answers to that beautifully, very beautifully, right? I mean, the very first instinct that I wanted to actually know to say is that this the power of reiteration on multiple operations at the same time. What it actually does is that you can check multiple things at the same time. To me, the beauty about tree is that its ability to reiterate. Hands down, the reiteration part is because it can check multiple operation. WUL. Crazy. To me that's wow. It's wow really. Like it's so beautiful. It's just a form of art, I would say. Yeah. Yeah. So I would actually argue that like tree, its ability is to be able to do reiteration, and within the reiterations, they can perform DFS, where they check the deepest of an item. It's really 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 cool. Like sure, DFS is like a passive spell that actually uh, has its own formula to be able to check the deepest of an item per se, and like we are able to do that, which is Operation L. We are actually I'm able to like because of like the property of tree being able to reiterate every single note. So one more key thing is that it performs on every single node. Each and one of them will perform all this every single operation, and one of the operation is the passive spell DFS. This item over here, Operation L, is doing the DFS. It's doing activating this passive spell. It's, to me, wow, that's crazy. That's crazy. And I mean, sure. At the end of the day, you also will always want to use the brute force to actually try to argue against our character. And like when we talk about tree, we talk about reiteration, right? But if you were to brute force, you won't be able to actually perform. So say you come brute force over here, right? Cool. But you can't keep on operating on the same item over and over again to do all of this every single operation. Is usually not the case on how brute force things works. So if you were to actually this is operation O, where brute force you're trying to sort of come to this value and actually perform this item and this item and this item. I think one better way to actually argue is that whatever tree is doing is that there's some form now my first word was checker, so let me find if there's really a checker in the trees. Okay, like the first item that comes to my mind, let's say this is operation N. Will I be able to actually perform operation W where I use a certain formula to actually calculate 1 plus whatever? I don't really do that. I usually will just come to here and I go to my next node already. That's operation N. But for operation W, it's saying that I'm going to use this formula to actually calculate everything before going anything else, and then perform operation L to check whether, okay, are we still within the scope of things. are we still answering the Leetcode question or not? Because Leetcode question is asking that if height more than 1, I'm out of the game. But operation and brute force is going to come to here, and it's not going to think much and go to the next node. And the moment you go to the next node, sorry, you're out of the Leetcode question scope already. Leetcode question is asking more than once, you're out. And if you go to the next node without actually answering that, I'm sorry, brute force, you're also out. So that for me, it's how I use tree to actually argue against brute force in my thinking of things. So yep, I mean, with that, everything comes to an end.